First, let me say welcome. I appreciate everyone being here today. Hopefully the weather is on an uptick, and but we do have coffee and donuts in the back. There's probably a restroom nearby. Obviously, you know where the exits are. So again, welcome. I appreciate you all being here today. My name is John Salzman, and I'm the relatively new Director of Environmental Health and Safety here at UT. My first day was July 15th, and I think on July 16th is when Elena first started talking to me about machine shop safety. So it was a pretty quick introduction. We really do appreciate you being here. Elena's giving me some talking points here, but I'm going to try to go through them pretty quick so we can get back on schedule. If you look around, I think you see that there's a fair number of you here, probably somewhere 40 plus, maybe 43. I don't know the exact number. How many? 41. That's awesome. So why are we here today? It's because this is really important. I'll share a short story with you. First, you all probably have all already heard about the tragic accident that occurred at Yale in 2011, where a student was tragically killed in a machine shop accident. Terrible. But that's not the only reason we're here. Many of you run machine shops across the campus, and those are important for students to get their work done, for the facilities to get work done, for research to get done. The fastest way to get a machine shop closed is to have a serious accident. So when the machine shop's closed, you can't get, whatever it is you're trying to get done is not going to get done. So that's really why we're here today. We really don't want to have accidents. We definitely don't want to have tragic accidents like we had at Yale. I can tell you this is an important topic for management at the University of Texas at Austin. And beyond that, it's a really important topic for EHS programs across the country. In early November, I met with 35 other EHS directors from around the country. California was there, North Carolina, Wisconsin, Kentucky, South Carolina, a myriad of directors. And we met for a day and a half, and we probably spent an hour of that day and a half talking about machine shop safety, because it's so critical. Obviously, parents entrust their students to our care, and surely they don't want to hear about Johnny or Jane or someone else, their daughter or son got injured in a machine shop. So it really is critical. Probably don't need to say much more other than thank you for being here. I hope you will pay attention. I hope you find this useful. We will be soliciting feedback from you about this workshop and future workshops and topics, so please give that some thought. With that, I'm going to introduce Elena Capsuto. She's an Assistant Director in Environmental Health and Safety, and she sort of wears many hats. Call it physical safety, asbestos, mold, machine shops, fall protection, all those kinds of things. But she does an admirable job, and I'll turn it over to Elena and let her sort of introduce the rest of the workshop. I appreciate you being here. Have a good day.
Really quick, I'll tell you what's going on. Okay, so you've already met John Salzman, and I'm just going to give you a quick update of what we've done so far and where we're going. And I'll introduce Don Gardner, who has graciously donated his time. He's a consultant that has, can you guys hear me in the back?
Yes.
Okay, good. He's done Yale's assessment. He's done several of your shops in-depth machine assessments. Then we have a presentation by Mark Phillips on anti-restart. Daniel will be introducing some unique guards on equipment that is not as common on university. We've got lunch, a roundtable discussion. Karen's going to introduce the message board, and then we've got a closing. Okay, you guys each have a bag. And what's in the bag? What we put in the bag were grinder scale, for, which you'll notice this is one of the requirements on the machine inspection form, a gotcha stick, which I do not have my gotcha, thank you. And what a gotcha stick is, it shows you how far your fingers can be based on the size of the opening. So if the opening is that wide, you can safely have your fingers over here. So opening that wide, your fingers can be here safely. We put high noise reduction rating earplugs for you to keep. Not going to want those back. Catalogs of just some of the most common machine guarding companies that sell guards. We don't support any of them in particular, but we want to give you guys some place to start. A list of the current shop supervisors that we have, and a new and improved inspection form. Yay. Okay, we're just going to have a brief review. So, as you guys are all aware of the accident at Yale in 2011, from that came the student training. We convened a working group of several members here. Joe Kakuda, we have mechanical engineering, facility services. Basically, it's an online training which introduces students to the university rules, which are also on this poster. And if you need any of these posters, we'll be happy to give them to you. But a lot of it's common sense about not wearing, not listening to a music player, things like that. They do the hands-on, they do the online training first, and then they'll pass the test. Also, we've embedded some safety videos on the most common pieces of equipment, like a bandsaw, drill press, lathe mill. And then they have the hands-on training, where a faculty or shop supervisor will show them how to work on the piece of the equipment, and you guys will sign off that they know what they're doing. Oops. Okay.
Good change.
Okay. So we don't ask employees to take the OH 500, the student training, unless they have little to no experience in the machine shop. They have a severe near miss, which means an accident would have occurred that would have killed them or sent them to the hospital and created a permanent disability like a loss of a hand. Or you have a serious accident. It's very rudimentary and it's painful for people to go through that have a lot of experience. So it's basically just intro for people with very little experience. Okay, there we go. Did I do that? Right, hands-on training. Oops. Okay. Then we also created a shop supervisor training, which is OH 506. And basically what this is, we had Dawn come back and we filmed how to properly and safely inspect the safety devices on the most common pieces of equipment, a drill press, a bandsaw, a lathe, the radial arm saw, a mill. And this is required for anybody who is in charge of shop operations or will be filling out the inspection form. For student shops, you have to fill it out once a semester. If you're not active in the summer, you wouldn't fill it out in the summer. And for employee shops, a minimum of once a year. You guys are always welcome to fill it out more frequently and to add additional requirements. And any equipment that's not on there on the list, add it. So if you have a planer, we want you to add that too. And if you need some tips on how to inspect that, if it's not available on the website, just give us a call. And Daniel and my contact information is on the contact list. Okay. It can be a little challenging to find where our information is. So this is the main EHS webpage, and my group is the Campus and Occupational Safety. So you click on there, and then you would go to Shop Safety. And then this is where all the shop safety information is that's related to equipment. So we've got the student training. We have this in PDF form for shops that employ people outside of the university. They can do that. There's the machine guarding training, the shop safety checklist, and that's so you guys can document when you've done the hands-on training for the students. And then the machine inspection form, which there is a copy in your bag. And at this point, we're just asking you to keep the inspection forms, and when we come around to look at your shops and machine guards, we may ask to see that. Okay. For any electrical work that is done on campus that you employ your electrician or you do it yourself, you got to make sure that it's up to National Electric Code. And what you would do if you don't have an electrician on staff is you would submit an SR10 to PMCS. and they can come over and give you an estimate for the work that needs to be done, and we can help you prioritize in terms of what should be done first. I know that several departments have successfully put in requests for WCI money to get their guards fixed and some of the electrical updates, so that is an option for some of you that want to submit for that. Okay. As we were going through this, we've been noticing some holes that we needed to close. We're also running the hearing conservation program right now. And we've put noise dosimeters on people that run machine shops. And for many of them, their hearing levels were below 85 for a time-weighted average, which is about the sound of a residential smoke detector. But we know that when you run certain equipment, it's still very loud. So in order to be protected, what we've decided to do is either the safety coordinators or managers such as Bo, Jennifer, or Lee will go around with an area monitor, and if the equipment is 85 or above, they'll put a sticker on it. And then the employees would wear hearing protection that the university would provide. Typically, it could be earmuffs or earplugs. And then you would read a one-page handout on hearing protection. And we feel like this is protective because you're still wearing hearing protection, but it's not overly onerous. People who are not being exposed to 85 or above don't need an audiogram, so you're not required to do that. So we'll be going through as we do the follow-up inspections. What you guys should do again is just wear the department provided hearing protection, read the one-page handout, which is on the hearing section of the campus and occupational safety thing. And then again, you're not going to be part of the annual audiogram. You don't need to go through the 45-minute training. In addition to that, what we realize is that there's some handheld equipment that we feel is very loud. So to close that loop, what we're going to be doing is the safety coordinators and my group will go around and take area readings for loud pieces of equipment. What we need your help doing is identifying that. We have an idea that chainsaws, some drills, some equipment that Park and Transportation probably uses. If you can send us that list, we want to add it so that we can either give you advice like it's below 85, or for something like a jackhammer that might actually put your guys in the program. So we just want to be protective for both the fixed equipment as well as tend to be large handheld equipment. So we're trying to close the loop on that. Okay, it's again the same deal. Your department would provide hearing protection being plugs or earmuffs, and we would make sure it would reduce it to a safe level. And just read the one-page handout. So it's not overly onerous. You guys can do it in a departmental meeting, and it ensures that we are protecting our employees that use equipment not throughout the day, but periodically. Okay. Many of you have had an in-depth assessment by Dawn. We've gotten some money to finish that up. We're going to be finishing up housing and food, doing some of the student societies, and finishing up at PRC. Please let us know if there's a student society or machine shop that we may not be aware of. A lot of this we've heard through word of mouth. And I know that we've got several of the departments here that we've already done, but I know that we're going to be finishing up Lake Austin Boulevard and CEM folks and no. So let us know about any other machine shops that we're aware of, or student societies. Okay, we're going to be filming the presentation, and we're going to put that on our webpage so that new employees or anybody that's missed today can go over that. And again, if you have any questions on machine guarding or anything hearing related, you can call the main EHS number if you forget Daniel or my name.
Thanks a lot, Alina. Good morning, everybody.
Morning.
Again, I'm Don. People say I sound like Ray Romano. Everybody loves Raymond. So you can call me Ray. They also call me Machine Gardener. But I've been doing a lot of machine guarding assessments over my career, most recently, probably the last 20 years. But it's been, I'm very excited to be here. Obviously, know some of you, have worked with some of you in your shops. You guys are doing some really good things here. Yeah, I think the opportunities are here, but Elena and her staff, you really should be proud about this. You have so many shops here, so much stuff going on. There's the difference between the physics guys and the art guys. I mean, you can't just apply one solution to everything. This is a great opportunity to share it all. I think that if nothing else, and we're going to have you discuss things at your tables here, that's the real value. Because there isn't just one answer. I've got a program here I want to go through pretty quickly, talking about just hazards and risks in general, what the difference is between a hazard and a risk. It could be reviewed for some people. That's fine. We'll be able to, to really, and we're going to have an opportunity for questions and whatnot at the end. So please, bring up whatever the issue is. I don't know it all. I've had good perspective here now over the last 5 years or so since the Yale incident. In the university setting, before that it was primarily industry, business and industry. But machines are machines, and there are some commonality. So we'll talk about some of these so-called either requirements or standards. You can look at it as a requirement, kind of a standard. These are things that are out there that are being done with machines to protect them. And then both from a regulatory or consensus standard, right? Not necessarily legal. And then some of the options that you have. Finally, if we have time, just kind of show you a little bit about to simulate a risk assessment, how you might go about doing that. You have an inspection checklist that Elaine's group has developed, but if you want to go beyond that and say, if I want to evaluate which of these machines I should be more concerned about, there's a way to do that. So here's how I define a hazard. There's other definitions out there. You can include environment, but pretty typically it's something that's going to have a harmful effect on a person. It could also be a legal hazard, right? I mean, there are lots of companies that have hazards associated with in the regulatory environment. But let's call it an act or a condition. So it could be just a physical condition, which if I walk into a shop, I might see that the act would be hit or miss, depending on when I was there, who was using what piece of equipment, right? I mean, that's a big part of the. I wasn't here last year, but in 2012 and even, I think it started in 2011. When did I happen to come into your shop? What was going on? And typically the machines were not running because that was the best time to evaluate them. So then, if somebody talks, at least a safety professional talks about risk, this is often what they're going to try to explain, is that it's this combination of the severity, the potential severity within reason, most likely or credible injury, but worst case that's credible, with some kind of exposure to that hazard. Right? There are hazards all over the place. You use machinery, you have hazards, but what are people exposed to? And it's really tricky to get into this probability area, right? How likely is it for something to happen? So I've been working even within my own group on that, and just to try to maybe deal more with the frequency of exposure. How often is someone be in a situation where they could actually be injured by that hazard? And some of that is going to depend on some of the factors that I know you're working on, relative to the administrative and so on that I'll talk about. You could also look at a risk as just a poorly managed hazard. There's hazards, and then if you manage that and put some controls on that, there's still risk. It's not zero risk, right? So there's different levels there. In order of effectiveness, and this is very important because, for instance, I won't use the example here. I was at the University of Cincinnati, big department that I was looking at. This shop supervisor had a large number of controls in place, but very few were in the what I would call this level here, the engineering controls. Now, the prevention or elimination, you just wouldn't have, you would just get rid of your machines, right? Well, very clear. John made it very clear. This is very important to the university, to the students, to various departments. You need to use machinery. So this isn't often a very good option. Sometimes, though, you might want to outsource something. Sometimes you want to say, well, we're not going to do that here. We're going to let someone else assume that risk. That's risk avoidance, and that's through prevention or elimination. Chemical. Sometimes you can just say, that's it. We're not using that chemical. That prevents the exposure to it. With machinery, it's a little trickier, but that's really should be your first option. Is this something that we have to do here in this shop? Some of the student organizations now are not using equipment anymore. They're going to go to someone who maybe knows how to better use that equipment. They've eliminated that exposure. That's the most effective. You can't get hurt on a machine that's not being used by either your employees or your students. Not an option for a lot of us, right? It's not. But the next one down there is really what the focus of this is, right? It's on the engineered controls, the guards, the barriers, the sensors, all of that stuff that, yes, it does rely on the user, on the operator, but not quite as much as the next one down, which I think a lot of focus is in a lot of places that I go to. So prevention, engineered, and then the management and administrative controls. A lot of that has been kicked into higher gear as a result of the Yale incident. When I worked with them, they actually certainly got rid of the lathe that was involved with that injury and anything like that. So I mean, they spent a lot of money replacing equipment, but needless to say, the money was forthcoming only because of the incident. But then they spent also a lot of time here with the administrative controls. The shops are not open from midnight or 1 o'clock until 5 or 6 a.m., whatever it is now. That's it, they're closed. You can't go into these shops now. That's an administrative control. Kind of elimination too, but it's more with the rules and procedures and instructions. I'm not saying that these are ineffective. I'm not saying that these are not important. They're not going to be as effective as these. We need to, my personal experience with this is, you need to do a better job with this, continue to maintain and build this, and not rely so much on this. The signs and the placards, after a while you don't even see the signs and placards. I'll walk in and I'll talk to somebody about a sign. Sometimes I'll say, oh, yeah, I guess, what sign? I'll come back and say, yeah, I guess there is a new sign. You don't even see them anymore. Again, I'm not saying eliminate them, but they're going to be the least effective in the so-called hierarchy of controls, prevention and control. That's the order you want to try to follow. And then by the process of elimination, okay, tried that, nope, we have to use that machine. Can we guard that machine? Well, we've tried to guard that machine, and today we'll hopefully find some more creative solutions to some of these things, but then continue to work your way down. All right. People in this room, when you're standing and introducing yourselves, I've met a lot of you, a lot of folks I have not yet met. I suspect you're pretty familiar with this, but I'm going to go through it pretty quickly. The hazards associated with your equipment, right? There are hazards. There are various things that these machines do to, typically to wood or steel or something, that if it does that to the human body, it's going to be a problem. So you've got mechanical, so-called mechanical hazards, so-called physical hazards. So if you're not just looking at the motion, but that things can fly out, obviously air, even I did a laser safety evaluation at a facility last week up in New Hampshire. I don't typically see it. This company fabricated or they did work with lasers. Almost every machine in there had a laser in it, and that's that was kind of unusual. So any kind of physical hazards associated with your machinery. And mechanical, this is a great picture because it shows these so-called nip points. So people like to talk about nip points. What's a nip point? Right? If the gear is turning this way, you've got an in-running nip point there. Now again, this is behind a cover, but some of them are exposed sometimes. It depends on the direction. This is going in, this is going this way. The belt's here. That's an in-running nip point that represents a hazard. Exposure to that at a risk, you could, that's where you get into discussion, but it clearly represents a hazard. I love this one because this is one of the oldest drill presses in the facility, in your campus. And there are definitely nip points on this. When they built this machine, this is a great old machine. By the way, I do love old machines. It's not like oh my God, get rid of these machines. But how do you bring them up to today's standards and to protect people from these nip points? The belts are exposed, everything is just, it's all out there in the open. That was not the standard of the day. Rotating shafts. This is a more modern lathe than the one that the student was killed on, but she was not killed on the chuck or the point of operation. She was killed on the lead screw. Her plane tail got caught on the lead screw. So rotate. I've always looked at these as hazards and to a certain degree risk, but it certainly changed my perspective when something like that happens. So rotating shafts in general represent hazards. Exposed rotating shafts, things on shafts on motors and such that aren't necessarily going to be protected and don't look like much to you because you're familiar with it, but do represent hazards. Then there's transverse motion. Again, just quickly, just showing you some things here where somebody, I worked at, there's a Sikorsky helicopter has these large, I think they're grinders, that surface grinders that were going back and forth in sync, and then when they got out of sync, they could actually squish somebody walking between them, and we had to look at that. So transverse motion, even if it might not crush somebody, could still injure people. And then the crush, pinch, shear points on something like a powered shear here, or at least some of you, is anybody here from ARL? Yeah, so you recognize this one? This is I think this is out there. Maybe not. I can't remember. I've seen so many pictures, so little time, but this is a little press brake. And there's a pinch or a press point there. Very difficult to guard something like that, right? Because sometimes you got to get your hands really close. That's the kind of stuff that we want to talk about. What are the challenges with regard to some of these machines to at least improve the safeguarding? Do something. Give people something that they can use maybe even part of the time. Don't forget about some of the auxiliary equipment. Call it a shear point, call it a pinch point, whatever, where people can get caught in and between, even if it's not necessarily at the point of operation. Let's see if I took a video of this at this. I think this was a Sikorsky plant. You can see just on the surface of it, what the heck is it? Okay. So I told the guy to start the thing, so you're standing near there. It came right down to the floor. So I'm working on, you can kind of see up here, anyway, the point of operation is up here. You're standing near there, boom. I mean, there was no requirement for steel toe shoes in that particular facility. So sometimes you have to see the machine in motion. It's a challenge for me coming in any given day to your shops and really understanding how some of these machines work. I'm certainly familiar with most of them. A point of operation. That's a term that safety people use. I'm not sure everybody uses that same term the same way, but it's where the work is done, right? So on this, it's a little hard to see, but in this shot, you've got a drill press where the point of operation would be where the tool hits the part, if there was a part in there. Or if you were, at the front of the grinding wheel, right there on the tool rest, or on the disc sander, right? That's the point of operation, which varies tremendously by machine, right? And the points of operation represent hazards. The exposure to hazard is what you're doing with the part or whatever, and we need to look at that. We need to look at those hazards and then the controls that would be useful. Geology, right? You're crushing stones, rocks, whatever. This was behind don't look behind the curtain. I like to look behind curtains, and behind there is, people are not prevented from reaching in there, but a lot of things can fly out. There was some protection there, but it wasn't in the greatest shape. Sometimes guards are put on there, not maintained. Sometimes guards are put on there by the manufacturers, not going to work for you. Points of operation, it's interesting. Just one comment on that. If you purchase a piece of equipment, you say, well, how come it's not guarded to the current standard? The points of operation are really not the manufacturer's responsibility, they're the user's responsibility. Some of those other things are going to be controlled by or going to be covered by and guarded by the manufacturers. But typically the point of operation, that's up to the user because they don't have control of it. The manufacturer sells it to University of Texas, Austin. How are you going to use it? They don't control that. They'll put all kinds of warnings and stuff, but it's up to you to guard that. Certainly from a regulatory standpoint, even the standards talk about that. The American National Standards Institute, ANSI, who's responsible for what? When you talk about point of operation, it's the user. You folks are the users. So, don't assume that just because you bought it and it came in with, let's say, no guarding at all, is that okay? Not necessarily. Some machines have multiple points of operation. This is probably the classic machine that's got One, two, three, at least four in this picture, right? Different thing, very versatile machine, very tough to guard, right? The iron worker, so-called iron worker, interesting name of that when I first got into machine guarding. What's an iron worker? Isn't that a guy that climbs around on the buildings? So, guarding points of operation. Okay. So those are the different, quickly, it's just some of the hazards associated with some of this equipment. Requirements, standards, you know, I call them requirements. You guys are not as subject to, you folks are not as subject to some of the OSHA requirements that a lot of my clients are. That's okay. We can still talk about them from a overall standpoint. Even if there isn't a requirement in the legal world in OSHA, you've got this thing called a general duty clause. So if you look at it as a UT Austin duty clause, right? You have a duty to protect the users or provide an environment, kind of translate this, instead of an employment, let's say an environment free of recognized hazards capable of causing serious death or injury. Just use it for your own standard and then say, how am I going to protect my students? How am I going to protect my employees from serious hazards, which we briefly touched on, or not? The key term here is recognizable. What makes it a recognized hazard? Well, I didn't see that, you didn't see that. That's where these other standards come into play. That's where these so-called consensus, industry standards, National Fire Protection Association, Elena mentioned the National Electrical Code. That's a consensus standard unless your state adopts it as a regulatory standard. And that's the case with a lot of these things. So recognized standard, OSHA puts that term in there. I would encourage you to use that here, a recognized standard to the university or universities in general that can cause death or serious physical harm to, just substitute, you know, to operators, to students even, right? So you can easily adopt this kind of thing, and then, you know, the challenge is how do you apply it to your particular pieces of equipment. Well, OSHA goes on to have these general requirements, and then they have different ones by type of equipment. Not a lot in there, except for maybe in these mechanical power presses. I'll cover just a few here that are out there that I think can be, you know, you can look at them, and we've tried to look at them here in other universities and certainly in industry where you have these that are specific or unique to that type of equipment. I would be remiss without briefly mentioning the overlap here with energy control, right? You have machinery that's in operation that you're trying to protect and guard people from. But what about when someone's changing a wheel on a grinding machine or a blade on a bandsaw? Do you control hazardous energy properly here? If you were subject to the OSHA requirements, you would have to use lockout, tagout, and not just turn the power off, but lock the power off and test the power to see if it was off. If you were doing electrical work, you would have to have a qualified person using a meter, a volt meter, to check for zero voltage. That's how serious they are about that, controlling hazardous energy, if the power can be on. And if you're turning the power off, which you probably are to change let's say a bandsaw blade, are you putting a lock on that? That's the overlap here with machine guarding, because you're now taking off a guard or opening a guard. So it's not protecting, you know, that person anymore. That's all I'm going to say about lockout tagout, but there is definitely an overlap. Okay, so the so-called general requirements in the regulations as they are now are just that. They really don't give you a lot of guidance. If there's hazards, you've got to identify the hazards first. You've got to protect people from the hazards. What does that mean? Well, it means a lot of different things. It's a challenging area. You should have the guards, it says there, they must be affixed or secured. Even that is subject to some interpretation, right? You could ask somebody, is a magnetic-based guard acceptable? No. Have you tried something that actually is bolted or secured to the guard first? Again, maybe work your way down with that. Please look at this, the hand tools as supplemental to guarding. Very important for things like the push sticks and whatnot on saws and whatnot. Absolutely. Something that you want to keep doing, but that is, in the eyes of the regulators, not guarding. It's supplemental to guarding. It's in addition to guarding, but still important. Then you've got a couple more on the general side of things. Rotating, drums and such. That's pretty straightforward. For whatever reason, the regulations back in 1970, when the Occupational Safety and Health Act was passed, talked about fan blades, and a lot of open fan blades. And if they were up high, and we'll talk about guarding by distance, I think in a couple of slides, if it's above a certain height, then it's not exposure to that hazard, right? You don't have the same risk associated with that. But if not, then you've got to make sure that you can't, and that's where our gotcha stick. If you've got fans, you've got a lot of heat here in the summer, or maybe even most of the year, see if you can stick your gotcha stick through the openings of that fan cover. And you know, that's a good test, because Elena's fingers are going to be small, and my fingers are going to be small, and some of the guys' fingers in this room. So that's what they use. I talked a lot with some of you about securing machinery to the ground. Now, if it's a portable piece, if it needs to move around, then you should make it stable, right, so that it doesn't wobble, and so that you increase the risk or the hazard there. But if you can get a place for it, and that's the place, secure it to the ground. That's something that the regulations and the standards really want you to try to do. Now, other things that relate to, not necessarily the point of operation, but to machine safety. Now again, I know some of you are familiar with this. If you can't lock it out, can you unplug it? You know, new machinery coming in, or maybe modifications and upgrades that are made so that you can physically put a lock on something. Some of the older equipment can't do that. Automatic anti-restart, so to speak. If there's some kind of it doesn't have to be a massive power failure on campus here, but some loss of power to that piece of equipment, and then the power comes back on. Should not restart if there's a hazard associated with that. Low probability, but again, it's tricky to talk about, you know, how often these things might occur. Potential is there. Foot pedals are nice. You don't even have to worry about emergency stops if you're controlling, say, a drill press even with a foot pedal, but it should be protected so it's not inadvertently stepped on. So just some sort of cover there. Elena was talking to me this morning about this, about how can you reach an emergency shut-off or stop without leaving your normal work position? And what are the distances there? Do you need maybe more than one? So we need to look at control. That's after the fact, but it can prevent things from becoming worse. One of the reasons that woman died, one of them, or many, is that she couldn't reach any kind of a shut-off. I mean, she didn't die instantly. She couldn't reach a shut-off. She couldn't turn the machine off. So, and then any control with an easy reach. That's tricky with some of the machines are built for, I don't know, gorillas or something. It's very, very challenging. So maybe you can make some modifications. You guys are creative. The best, and we'll be talking about regards, the creative solutions you come up with here as a team or as teams, as different departments, I think are going to be the most effective. Because they're going to work for you, as opposed to a lot of places, some places they go into, I shouldn't say a lot. Guards get put on, not a lot of time is spent with either owners of the machines or particularly the operators of the machines. And what happened to that? Oh, I don't know, second shift, I don't know, somebody took it off. There's no explanation. Then certain pieces of equipment have other requirements. So I just put these up. OSHA has these different categories of the machinery. These are typically going to be woodworking. You can read them there. So yeah, you can get some more guidance from OSHA or from ANSI. There are ANSI standards, American National Standards Institute standards, for these different categories of machines as well. Do you have a library of the ANSI standards, the B11 series, for instance? Do you remember?
I don't remember if we bought it or if we can get it from.
Yeah.
Buy it.
You're an educational institution, probably like that. So, you take a radial arm saw, right? One of the things that's required, that's one of the must return to the home position. I found a number of them here and elsewhere. You pull it out and just stay. You pull this thing out, it slides obviously on a track, and it did not return to the home position. Either For some reason it wasn't designed that way, which I found interesting because that would be one of the things I would think would be built into the saw. But, or it was broken, or you had to add it because it was such an old saw. It's not that hard to put on there. And then, you know, the fact that this is just an exposed blade. Can you completely enclose that blade for an operation like this? No. But, you know, there are things you can do there. So you're looking for the hazards associated with that. You're looking at the controls which are out here. Can you hit that button in a panic mode and will it stop? I kind of use that as my, you know, can I palm that? You see this little thing here? I think I purposely got that picture in there. What's that?
Extension cord?
That little device. Extension cord maybe, but what is this?
On-off switch.
It's an anti-restart, and I think some of them are GFI now. Those are the more expensive ones. The little ones that are, I have one in my backpack. I know, Elaine, you have one in there where, on the 110, on the 110 it's like $20. On the 240 stuff, I think there's going to be discussion on that. So anti-restart, you don't want that saw to start up again. So, you know, the different things that I covered in my video. How many people have seen, I haven't even seen, how many people have seen the video that I made?
Just the supervisor training.
Just a few. Okay, all right. So I think this is one of the machines that I covered. Nice old wood lathe. Where's areas over there? There are some things you can do with that. Can you use the guards all the time? No. And of course, I'm not seeing what's going on here. I'm looking at a lathe going, not a lot on there from a guarding standpoint. In other lathes, I've seen other shops here. They have the, you know, there's a cage on top. I'm not saying that it can be used all the time, but a good portion of the time it probably can be. This one, you know, there was nothing. And there's a start-stop button there, but that one looked like maybe you could just, you know, if you hit it, when it's in the on position, it's going to stop. I'm not looking for any, I wouldn't be looking for any additional controls on that one. Is it secured to the ground? Does it have anti-restart? It's a pretty simple machine. Lots and lots and lots of drill presses out there. This one happens to be, I think, a nice little Delta, I think, with, you know, it's kind of a sliding one, radial turns. I mean, this is a nice old piece of equipment, but you can see there's some opportunity. There's hazards, right? There's hazards. What hazards do we see in this drill press? Based on the things I talked about, the categories of hazards. What would be the hazards associated with this? So there's a rotational hazard, right? There's entanglement hazard. What else? Well, the hazard, something could be flying out. I mean, if you look at it, you break it down to those different categories. Now, a shield on there that you secure to the arm here. Again, you have to, I'm not saying just slap anything on there. You have to work with, I would be working with, you know, with you folks. I have a couple of guys, a couple of teams that I send out. If we were in Texas, I'd have them here. I guarantee I'd have them here. These guys work with operators and get shields on it. Now, you know, the requirements are usually put on by, so here would be by the university. This is the requirement, and then, okay, how are we going to do this? And so my team could come in and help you do that. You can do that yourselves. You can, you know, avail yourselves of these resources to put something on there to guard from, protect from, entanglement hazard, the point of operation, which could be drilling your finger, which could be something flying out. You've got maybe a nip point there. I mean, this is an old machine, but it's a really well-made machine, right? These are, again, I respect these things. I really do. But I also respect the fact that it's not up to the standards. Okay, abrasive wheel machine, grinders, right? There are some common things associated with that. The little device, the little that will measure your 1/8" work rest and your 1/4" so-called tongue guard, thing that comes up and down at the top of the wheel. That's your gauge. That's the word I was looking for. That's your gauge to measure that. My experience is the grinding machines, nobody really owns them, so these things they wear or someone puts a different wheel on them, that's not adjusted. You need to constantly adjust those. How often your wheels are changed? Maybe they're not changed that much, so this doesn't come up that much, but when it is changed, is that wheel, in fact, if it's not been stored maybe too safely, it might have a crack in it. The first time you start that up, that's when you're going to find that out. know, this is grinding people stuff. This is the blotters, the flanges, free-of-form matter. Very important to mount those things properly. So here I'm just showing this the difference between the hard wheel. We're talking about the hard wheels for the tongue guard and the tool rest. So you would measure, you would gauge that there and there, versus a wire wheel. Not the same requirements, not the same hazards, right? You can't have this thing blow up the way you can with this, or the shards coming out there. That tongue guard will protect you from that. You're not going to be drawn in as easily here, even though, again, you want to keep that relatively close. The toggle switches on these things, is that something that you could hit in an emergency that's really going to... Toggle switches are different. They make some... The new grinders now, in my experience, maybe you guys have a different experience, a lot of the new grinders come in with this little, I call them paddle switches. It's not an e-stop, but I mean, an emergency stop on a grinder is going to cost more than a grinder. So the paddle switches, though, they're usually red and yellow. You just hit, you pull it out to start it, right? And it kind of pivots on a little hinge. And you push it in to stop it. Much better than these toggle switches from a safety standpoint. But there's an awful lot of these out there, you guys know that. Okay, so in addition to some of these requirements, at the point of operation or related to that, you've got mechanical power transmission. You know, you're not at an old saw mill or something where you've got these belts and stuff, but that drill press actually had belts like this, right? This was pretty common. But these are the kind of hazards, and you can have hazards associated, right, with these different components, power transmission components that need to be looked at and evaluated for hazards. And then, of course, you know, how can you reduce the exposure to those hazards or the risks? This is a beauty. This is an old roller that at the time we decided to lock it out because not only, I mean, the hazards associated with the rollers themselves, the point of operation there would be where? Where the metal is fed into the, either back and forth, right, into the rolls. But then look at the power transmission exposures here on the back side. This isn't bad right here, but the back side of these were open, so that's usually easier to guard. Something you might not think about and say, well, who in the world is ever going to... Don't start down that path because it's going to be like, you just stop guarding anything because, well, no one's ever going to stick their hand in it. You don't know that. You don't want to ever be in a situation, as I think John, I haven't even heard put that way. If you have an incident like this, your shop is closed. That's it. There's going to be all kinds of people crawling all over the place and asking questions. But you know, this kind of stuff is easy to guard. This is not easy to guard. But there are ways to do it. Don't forget about the power transmission. Even something like this, which is a hinged guard on top of a drill press, right? Some kind of drill press. Is that secure? Would you consider that a secured guard? It's hinged, it's easy to open. I personally want to have it so that, and this is a standard, I know a lot of you heard me say this, so that a tool has to be used to open. Now, if you're opening that, and you don't have to have it running, I know that some people have them running when they move belts up and down, but say you want to, you want to move that, shouldn't that now be control of hazardous energy? In this particular case, you probably unplug the machine. Unplug the machine. It's an extra step. Seems a little bit maybe over the top or too conservative, but those kind of guards should be secured so that not just a flathead screwdriver, maybe an Allen, just something on there so that a student operator's not familiar with it has to take that extra step and is thinking, well, wait a minute, I'm actually removing a guard. I'm opening it, it's still attached, that's the fallacy. What time do I have until on the schedule?
Until 11:10.
11:10, all right. More power transmission. There are lots of standards and requirements out there. You don't have to certainly know these all. We're going to talk a little bit about this risk assessment one, but Elena mentioned the National Electrical Code. Technically, the machinery should conform to NFPA 79, not 70, which is the National Electrical Code, but 79, which is a standard. You can read it there. For industrial machinery, a lot of good stuff in there. Same organization that created it, but that's what should control your modifications to your machines. It's in sync with the National Electrical Code. The National Electrical Code controls facilities-related electrical. And for those of you that are the electricians in here, you could probably talk better about this, but 79 is the one that I've always referred to in terms of machine, a description of what emergency stop should look like and how the control system works and such. Okay, so in the last few minutes here, let's talk about some of the safeguarding. You've got access control, right? If you don't have access to the hazard, the risk is much less through these kind of things. Or maybe, and there's not much of this here in terms of light curtains and such, but you can get pretty sophisticated. Most of your action is here, right? The physical barriers or the adjustable barriers, a couple of two-hand control systems. Don't just look at the operator. Well, okay, I'm here doing my thing. There's a backside to this or a size to this. It's about protection for other people who might be in the area. You can't possibly conceive of all the scenarios. Nobody could possibly conceive of the scenario that happened in Yale or some of these other injuries. Like, where did that come from? What was that person or other people? So don't just protect the operator. And again, the guards have to work for you. They started to, you guys have really made some great progress here. Again, very positive about all the work that's been done here. Obviously, more to do, but it will not be effective if it doesn't support your shop environment, your requirements, students' requirements. That's a challenge. This is not easy. It definitely is not easy. You can guard by distance sometimes. The top of this is open, I think. That's distance. You can guard the sides of that distance. Or if you had something way up here, I don't think that's open. But if I saw an exposed shaft up there, that's way up here. Some people are tall and can reach up there. So you got to use some judgment. But distance or height. Remember the 7 foot on the fans. That's the OSHA number. 7 foot from the working surface, not necessarily from the floor. So there's a platform or something. Anyway. That can be done, but typically you're going to have, this is a fixed barrier guard, right? This is bolted on there. And interestingly, what's this little thing here?
It's an interlock.
An interlock. So if you take off this, the machine isn't going to run. Is that required? No. Is that helpful? Depends on if people are taking this guard off sometimes, right? A lot of companies have interlocks because guess what? People weren't using the guards. This is a fixed guard, right? This is physically protecting you from the blades that are underneath there, planar. Or an enclosure, right? That's fixed. Some of them are bolted on, some of them are hinged, but if it's hinged, make sure it's secured. The adjustable barrier guards, right? I know this is not, this was an Italian machine. Was out at the structural engineering. Is anybody here from there? From here? Do you recognize that machine? Yes. Okay. So I like this machine. I don't know if you guys like it or not for what it does, but from a guarding standpoint, this seemed to have all the guards. Underneath here, there was an adjustable guard. You had a brake, and then you had this sliding guard, right? And then at the end of it, is that still in place? Is that it's still there, so you can still use it? It's got the nice emergency stop with the yellow ring. I mean, this was like the poster child. There it is. Can you make them all look like that? No, but you can. The hazards that they're trying to protect, even underneath the table. This is an adjustable barrier, which needs to be adjusted. The practice here should be if that's not in use. Now that didn't even have a blade in there, right? But if that's not in use, that should be all the way down. Or why would you want to just keep it down?
Forces the operator to adjust it.
If it's up like that, they're not going to adjust it. Human nature. You're just going to, some people might, but you're not going to bring it down. So I said this to this shop in Cincinnati. Every single time you look at, again, this was a place that had a lot of administrative controls. Picture should be, if that machine, when you leave that machine, that guard is all the way down. So the next person has to move it up. It's a little extra step. There are hinged guards. This is not at UT, but I thought this was an interesting homemade created guard for a lathe. It worked for them, okay, but you gotta see, you gotta come up with things. I'm gonna suggest you come up with things that work for you. This is still exposed down here, but this was where the action was, and they put a shield on it that worked for them. You come back, in 6 months, it's still gonna be there. Self-adjusting guards, right? On these saws, that radial arm, it lifts up and down. You got to be a little careful with the fence and such, but they're going to move. Could you still get injured? Yeah, but it's go ahead. It's quite seen one like that before. And then the interlocks. Well, you got this on your newer lathe. We'll switch there, but there's a key. The key overrides the interlock. You should say there's a switch, and in the switch there's a key. And if the key is left in the switch, in my mind, why bother to have a key? It gets lost. Yep. So, and guards are, you can't eliminate, you can put these engineering controls on there, but there's still people involved, right? So how do you control that key? Are you able to control that key a little better? Yeah. So you're not going to be able to use that all the time, but you want to make sure that you as a shop supervisor or some, when is it okay to not use the guard, and what other controls are we going to put in place? Should not be left up to that individual. I can't say that they're going to make a bad decision because of training and whatnot, but you've got a second person now in cahoots, right? You've got a second person who's going to say, yep, that's okay for this job, and here's how I'm putting more emphasis on some other control. I love this one. Whose is this?
That's Foreman Arts.
This is a motorcycle chain, right? Isn't it? This chain here, that didn't come with that saw. No way. I call that awareness, okay? You can stick your hand under there if you want to. You kind of see these things sometimes in the front of shears and such. But it tells you where, you're getting too close. If your hand is there, for some reason you're having a bad day, and you're holding something, and you feel this thing, it can be effective. I've never seen the chain radio alarm cell before. And it does a better job coming over that fence if you need to have that fence there, which is tough because if your guard is up on there and your wood is down here, you got that gap there. So I think that was a better way. I don't know why that was used. Was it something like that maybe? Or yeah. So is it going to work for you? I don't know. This is kind of awareness guarding. This is out of ARL. You can stick your fingers under that, but are you going to? It's more keeping you aware of there's bad stuff happening back there. We want to do better than that on something like this, the fixed barrier that I showed you earlier. I'm over my time here. Light curtains, you don't have a lot of light curtains. There's a lot of science associated with that. You can have two-hand controls and light curtains on some of these kind of power presses. A lot of stuff out there now that these switches, my guys use these coated magnets. If you want to interlock a guard, a shield or something, you can have it so that it slides across these Alexander plexiglass or something and makes contact there, and the machine won't run without it. You can put that on surface grinders and whatnot. Limit switches, etc. All kinds of great stuff. Scanners and cameras, and not something typically that you're going to apply here, but guarding is getting more sophisticated. Here's 79. I already talked about that. I would suggest that whoever's doing the electrical work become, if they're not already, you guys doing electrical work familiar with 79? Yes, no, maybe? Who's doing electrical work?
PMCS. We're silent in the back corner.
79, is that something that you're familiar with?
I'm not familiar with 79 per se, but I understand.
Okay. Something you might want to check out.
Componentry is happening.
Okay. Good. This is the end. So risk assessment, in addition to a checklist, if I went into your shop and said, let's assess risk associated with these different pieces of equipment. Like, hey, I'm looking at hazards, risk. Here's here's where the bar is being lowered or raised, whatever you want to look at. Let's say the bar is being raised, right? You have to get up a little higher to do a pole vaulting. What's an acceptable risk here now? Used to be maybe down here. It's rising, right? It's going up. That's not acceptable to have that unguarded piece of equipment, or the fact that you've got machinery out there that really hasn't been looked at recently. That's not acceptable anymore. So the bar is being raised. You don't want to go from here, way up to the gradually, right? People are going to continue. So the acceptability of some of these things. Things to consider when you're trying to understand your acceptability or tolerance for risk, right? Is it in conformance with what's out there, with what's recognized? What are other people doing? Tunnel vision is easy. You can just stage to stage, shop, and have to have a good record, good administrative control. But wait a minute, there's a whole world out there. Let's at least avail ourselves of that. And these standards that are out there are not created by the government. They're created by industry and committees and people that actually use this equipment. So, for instance, this is you buy your. I don't think this is a compound miter, so it's just a sliding one, right? So, is that acceptable? A lot of people have told me, not just here. They feel this is one of the more dangerous pieces of equipment, hazardous pieces of equipment that they use. That's the way it comes. That's the way you buy it. Is that acceptable? Or here's a good one, right? Is this saw acceptable anymore here? It's got guards on it. It's got a nice emergency stop and whatnot. Or, and I think Daniel's going to show something, right, Daniel? Where's Daniel?
Yeah.
You're going to show something on this, right? Yeah. So, what's the new standard for So, is that an acceptable level of risk? Interesting, right? All right, so we're not going to do this. We're out of time, but to analyze, you would try to determine how bad an injury could occur. You would try to look at that probability, which is more like exposure, the different fact. Trying to come up with this is really, really tough. But the frequency, duration, and extent of exposure. How often is that machine used, right? For how long? Extent of exposure. Think about that for your equipment, and then you can't guard. If you've got a big guarding child, you can't guard it all at once. So which ones do you want to start with? Think about this from the standpoint of risk, of severity, and then some sort of exposure to that probability. Because otherwise you're just going to be playing roulette. Okay, I had some things here to show you the matrix. You can do once you kind of rate these things. That's one example. Here's another example here where you, again, how bad can it be? How often you're exposed to it? You kind of put yourself in a box here, and then you decide: do we want everything to be low, or is medium okay? Something to think about. I apologize. This is very quick. That's the process to go through. You can see here some of the different tasks. Not just operations, how about maintenance, planned or otherwise, different things that you're running on the machine. It's all part of your evaluation, I'll call it, of the risk associated with the machinery that you're using. And I know some of these things are pretty simple machines, or seemingly pretty simple machines, everybody's got them, but you step back and say, man, what are we doing with this? Why are we using that machine for that particular job? We have to kind of do things we shouldn't do, maybe there's a guard on it we can't use. Can that be done on a different machine? Okay, I'm going to skip this. I was going to have there's just some examples here. Thank you very much. Again, a lot of information.
So my name is Scott Allen. I run the machine shop in mechanical engineering. It's one of the largest student shops we have on campus. So we kind of have two different shops. We have a student shop, and we also have kind of a journeyman shop where we kind of operate as a cost center. And we also have the students come in and operate the machines. So we've attacked we came through, I guess you came through, looked at our shop. We got our laundry list of things that we need to do. And so we started looking at, kind of the most important ones. And the toughest thing with these, with mills and lathes is they're all 208 or 240 volt 3-phase. And there wasn't anti-restarts out on the market that we saw. So we actually started thinking about it, Mark and I started looking into it, and actually it was all Mark, I'm not going to take any claim for it at all. He's an electronics technician, tinkerer extraordinaire, and came up with a pretty good solution to the anti-restart. So we've installed that on all the student mills, and we're looking to put that into the journeyman shop as well. So I'll let Mark tell you what he did. Thanks, Mark.
Primarily, the type of equipment we're looking at, as Scott said, is three-phase. And in your typical application, you're going to find that there's a disconnect on the wall or up on the three-phase power bus, and you've got a cable that comes down and goes directly into your machine. And there's just an on-off switch on that machine. And you've got to install an auto restart or a restart lockout circuit to prevent that machine from starting itself if power is interrupted. It's not the long-term interruption that's going to be your real hazard in my mind. It's a surge type interrupt from a lightning hit or something where the power goes away for like a second. Your person's in there cutting, and all of a sudden the machine power's gone, and then it comes back on and it bites the work, throws it, whatever. That's where your hazard comes from. Mr. Gardner's parlance, a restart lockout is a level 2 control. It's pretty high. So you get a really good level of safety when you install this circuit. And it also affords you the ability to install what we call an emergency stop type switch. There are many of them, we'll go into that, but when you do the anti-restart, it kind of comes along with the emergency palm slap, oh gosh, shut this machine off, kind of thing, instead of, oh, where is that switch, I have to turn it on and off. Why don't you go to that first circuit? It's an old circuit, World War II, at least. What it involves is a motor starter, because we're talking rotating machinery. It's going to be a motor that you're controlling here. So you want to get they're called a contactor or a motor starter, a relay that's designed to take care of the starting surges. You don't want to use just an inexpensive, oh, that's a 10 amp relay. You'll burn the contacts. Get a motor starter. You got your three-phase power coming in, and probably you've just got the 3 lines because everywhere on campus it's the 208 delta distribution on the 3-phase. You won't have a neutral available to use. So you'll have to talk to the electrical shop guys. They can pull a neutral for you. Don't use the chassis of the electrical equipment as your neutral if you want 120 volt control. So again, you may have to have that line pulled in, but that's a real easy thing for the electrical guys to do. The zone control guys can do that. I show an F1, a fuse. I like to fuse my switches. It's a safety issue. I don't know if that's a requirement of the 79 code or not. Depends on if it's all going to be in conduit. I put a fuse there. The way the circuit works is your power comes up to the start switch, which is normally open. You push that. These are momentary controls, momentary switches. Current goes on through the normally closed stop switch and energizes the motor starter relay. Your relay is closed, turns the motor on. When you want to stop, and the MS1 switch D, that's an auxiliary contact on your motor starter. That's a normally open contact. It closes with the relay and bypasses the start switch, so it stays running when you release that normally open momentary start switch. It locks itself in until you push the stop, and then everything falls out and shuts down. You might want to note that in that stop circuit between the stop and the relay is where you put your limit switches or your guard control switches. If you want the thing to shut off and not restart, if somebody takes a cover off or a guard off and you've got a limit switch, that's where it goes. Okay? If you've got a door, it's going to access the power that you want to make sure turns the thing off if somebody opens the door. Put it in series with that stop switch. In our student shop, yeah, I'll preface this. I recommend that you buy industrial rated NEMA 4, 4X, NEMA 12, oil-tight, watertight switches and enclosures. You can buy lesser switches and controls, but they'll cost you more in the long run. This is the type that I'm calling, this is an Allen Bradley, it's my favorite, Siemens, GE, any number of companies make them, but if they're rated for oil-tight, watertight, the other thing that comes with them is that they're modular. So if the contacts wear out, you take the contact block off, you put the new contact block on, you're back in business. Somebody hits it, they break off the knob, it's modular, you replace it. So your parts cost for keeping all of your equipment running goes way, way down. This is an Allen Bradley start-stop switch from 1957. This is the current one. They're interchangeable. When you buy these industrial controls, your replacement parts are always going to be interchangeable. Don't go the cheap route. The other thing that happens with these, if you notice, the start button is flush. You have to push your finger in to get it started. Somebody can't be swinging around a piece of material and accidentally turn the machine on. Your stop buttons are raised, so that all you have to do is slap it, okay? That will shut the machine off. Same thing with the individual ones. You can buy them with the finger guards. These are illuminated ones that we used in our shop. Stop button, again, slap it. You can't accidentally turn the machine on, but you can see that it's on from the side. You have to put your finger in it. All of the components are interchangeable, and they're all industrial. This is the box that we hung on our wall, and we used a motor start. We also put an overload circuit with an adjustable current trip. I've got a spreadsheet that didn't make the display, but part numbers for these are readily available. Gaskets on it. If you're going to be using cutting oil in your process, you're going to splash oil on all this stuff. In the theater shops, dust is going to get everywhere. These switches are immune to it. You won't ever have a spark or start a dust fire. This is the basic generic circuit for an anti-restart. We also used illumination in our shop, in the student shop, which gives our TAs the ability to look around the shop and see which equipment is on and off. It also tells you that something's happened to that machine and it's lost power just by scanning the shop. So you can come in the morning. Why don't you go to the next slide, please? That's the wiring for the lamps. In this drawing, and you can change it if you want to, we went with the industrial convention that if the red light is on, the machine is off, and the machine has power. If the green light is on, the machine is in operation. Some people like it to have it the opposite. But that's what this design does. Again, these diagrams are available to you. We had one additional requirement in the student shop, which was, if those of you are familiar with mills, they have a high and a low speed, and you have to turn the motor on clockwise or counterclockwise depending on which speed you're using, because the spindle changes, and we didn't want the students to be able to run the mill accidentally in reverse and chew up the tools. And the next slide shows what's involved to do that automatically. And I'll be happy to explain this to anyone, but there's a sensor on the gear shift. It configures the rotation on the motor, and once the motor is turned on, you can't change the direction of it. So after that, we haven't had any students burning up $100 mills by running them in reverse and trying to cut with them. That, again, is a little bit specialized. But that's available to you also. To surmise, in order to do these controls, you will want a job box to put your motor starter in, that you can keep that sealed. You'll need some sort of a pair of switches on and off, and you may need zone to come in and pull a neutral wire for you for your 120 volt control. That you can use this depending on how you size your starter for 240, 380, 480, whatever voltage level your individual machine needs to operate. Buy a motor starter, and some machines you may decide that you want to make sure that it's hands-free so they can't get their hands in there. So you have 2 start buttons in series. All depends on the level you need to go to, of control that you need to go to. On a machine that had the toe crush possibility, garage door opener interrupt circuit. Do a perimeter around your machine so people can't get their feet on. There are a lot of inexpensive, straightforward levels that you can go to protect your machine, and any and all that can go as a series switch in the stop circuit of the main control relay. And I'd be happy to consult or give guidance. We've got a spreadsheet that has a list of these different switches and their part numbers with retail pricing, new, old, stock, surplus, and used. That's available to anybody who didn't make this presentation, but I've got it for you. I guess we're open to questions. Yes?
Average, how much should it cost for parts, not the labor, to alter your machines, maybe stop and monitor and stuff?
What did you come up with here?
About $700. We used all used parts
Is that per machine?
per machine, yes.
And, yeah, that seems high to me. Yeah. My spreadsheet has all of the different switch possibilities listed in switches. You only need 2 of them. So, I would think more in the $400 to $500 range for, to buy the parts. We're going to an extra level on the ones we're installing in our Journeyman, and there were several quad boxes on the back. Well, there's room here, and we water jetted out for the outlets, so everything is going to be on the one box. You can be creative.
That's good for digital readouts or auto feed.
And don't hesitate to look on the surplus market. There's a lot of new, old stock, industrially rated boxes, switches. How about 40 of these for $200? This is normally $120. A transformer, isolated, illuminated, industrial push switch. The stuff's out there. You have to look for it. It depends. Do I have to do 1 machine or do I have to do 30 machines?
But if you can't afford to do the 30, do the risk assessment and decide which machine are you going to do this year, or a couple of machines. And then over a period of time, you get them all done.
Yeah.
It is some costly, but if you're creative, maybe Mark can facilitate you finding some of this stuff. That's a great deal.
I can always give you direction real quick to where do I find switches, what's out there. Other questions?
I have one for you
Yeah.
possibly. How much are the retail giveaway for 240 volt prepaid motor starters or anti-restarters?
I'd have to go to my team. I can certainly get you. We're putting this stuff on all the time, as you can imagine. A lot of these
Depends on the
machines
need.
are not-
Yeah.
I don't know.
The thing again I want to stress about the industrially rated controls is that they're modular. And if any single part of it goes bad, if a contact goes bad, one contact goes bad in your 3-phase motor starter, you take that contact out and you put one more contact in and it's back and running. If the coil goes bad, the coil is replaceable. If the contacts on these switches go bad, 2 screws on the back, you take the wires off, put in a new contact block, and you're good to go. So you don't have to replace the entire item because one part of it failed.
Larry, did you have a question?
Yeah, we put all the anti-starts, emergency stops, and all our equipment in the shop.
Okay.
For the power plant. It was all bought, our electrician supervisor bought it all. And they came to around $2,400 for e-stops, anti-starts for 3-phase, 208.
How many pieces of equipment roughly?
A bunch of it.
What's that?
We have a bunch of equipment over there. You saw it all.
Yeah, right, so I mean, that was a lot
We
of.
put e-stops,
Yeah.
anti-starts on all of it.
Yeah, wow.
What was the price of?
I think it was around 2,400 for the material.
For each machine or?
No, total raw.
Oh, you had easily 25.
I have to get with the machine shop, with the electrician supervisor, because he's one of the order it all, and his guys, put it just.
$100 for a motor starter, enclosure, and switches.
See Larry.
Yeah,
See how we did it.
that would be pretty good. It's possible.
That's what I
bought
believe the price
20 of these
was.
boxes at $20 a piece. So depending if you're shopping well, you might be able to do that. Again, he's buying for 20 of them, he's not buying just for one.
Yeah, we bought for the whole shop at one time, so.
Right.
Through one of the electrical dealers, he was able to get a good price.
Sure.
And Elena, did you say there was possible funding?
WCI, that's the workers' compensation. It's open to any department you can put in. I know that facilities and PMCS and McDonald Observatory were successful in putting those in. And I know that Neil Crump would be happy to lend you the spreadsheet so that you can have a starting point for departments that maybe don't have the same resources that utilities had.
Yeah, my shop got, what, $5,600?
Oh, did you? Oh, I forgot the utilities also. So there's opportunities, and that's coming up in May, I think.
Any other questions?
Thank you.
Talk about unique guards that we've seen on campus. Just to kind of reiterate that you can make a homemade guard for certain applications. You don't always have to purchase a manufactured guard. We talked about anti-restarts. Here you got 110 volt. We have the plug-in anti-restart here, or you can use one of these where that goes to the wall, that goes to your equipment. Here we have scroll saws. We wanted to have e-stops on these, but if you put an e-stop box on one of these pieces of equipment, you're going to knock it over if you try to push the e-stop. So we put some foot pedals on there. It's an easy way of substituting for an e-stop. We've got that was architecture. This is from Jester. Drill press. We've got chip shield. There's different types of chip shields. You can have a chip shield that is, flat, just a flat surface. You can have a rounded one. Your biggest thing is who's working around you. Is there someone working on a grinder right next to you? So they're focused on what they're doing. You're working a drill press right next to them, and your chip shield is flat. And something flies off. If it goes off to the side, it's going to hit the person. It could hit the person next to you. So you want to be conscious of your surroundings, which is all part of the risk assessment. Making sure that you understand what's going on. They've got their spring-loaded chuck key right there. We've got the e-stop up here. Like I said, the actual stop button is raised. This is a fairly old drill press, but the existing start-stop buttons were adequate for what we needed. I can think of on this one. There's a chuck shield on the actual drill press right in there, and this didn't need that much work. We just added chip shield and we're good. Panel saw. Raise your hand if your shop has a panel saw. I've got one, a couple. Yeah, everybody's got these. So this one is from geology. Originally we were always looking for an e-stop and an anti-restart. Well, certain equipment doesn't stay on if you're not holding it. It's not engaged by you actually holding a trigger down. That kind of eliminates the need for an e-stop. If you're actually using this equipment and you remove your hand from it, the blade's going to stop. And same thing, if you're using it and the power goes out, your typically gonna let go of it and say, why the power went out, so there's no need for anti-restart.
Daniel? On this in particular, I don't think I mentioned it. Some of these have little devices, little things on the handle so that you could keep it running.
Right.
And that would then,
Yeah, in that case, if there's a way to interlock that trigger, you would need some way of stopping the equipment. But most panel saws, chop saws, miter saws, you have to actually have your hand on it to make it work. Here we got routers. These are adjustable guards for routers. I think one is from PAC and one is from Geology, I think. So it's just an example of something that you can actually adjust before and during while you're doing the work. Right. Here's some examples of some really old equipment that was retrofitted with brand new emergency stops. These are both out of metal. We've got a drill press over here, and then our grinder with nice new E-stops. Radio alarm saw. This picture gets the word for being talked about twice. We've got this nice blade guard on the side. This is out of geophysics for Fred Taylor. This is a rock saw that they have out there that they cart outside and sprays water everywhere. So the outdoor outlet they retrofitted with GFCI. I think they even turned down the amperage. I think it was at like 60 amps. And they took it down to 15 or whatever they needed. And then if you look right there, so this is an E-stop that they designed for it. And I got a couple more pictures that show us up closer. It's kind of like like you ride the bus, you pull the cord to let them know you want to get off. This red cord goes around the perimeter of the equipment, so no matter what side you're on, you can yank that, pull on that cord, and it'll actually stop the equipment.
and what's interesting about those is, excuse me, Daniel, it's not too tight and it's not too loose. If it's too loose, it's also not going to work. So it's just the right tension. So if you pull on it, yeah, it'll shut it off, but if it's also defeated or someone says, I'm just going to take that off, that switch will go in and it'll also not work.
Right. And then they actually put 2 levels of ground fault protection. They put a GFCI on the actual machine in case someone, took it to some other part of Pickle and plugged it into an outlet that didn't have that protection. They're spraying water everywhere. They're still going to have their ground fault protection. I think we got, a little closer up picture right here. You can see the cord, and then there's another one that runs. Yeah, you can see. So this is the back side, so it runs all the way around. And so that's an example of us, people who use the equipment, understanding the safety needs, and then balancing that with how they're actually using the equipment to make it work out.
Those are commonly used on those power rollers too. Think about how challenging it is to, the guard the ones that you feed the metal into the rollers. You can be more creative with that, but to have something like that that's on both sides, right, that you go back and forth, nice. After the fact, right, I mean, it's an emergency stop after maybe you're starting to get drawn in. It doesn't prevent the start of that injury, but it certainly affects the severity.
Okay, the next presentation is something that we're going to try to have all the shop supervisors, have all of y'all be able to communicate with each other. UT List, has anyone used UT List before? The email-based group discussion kind of thing. So we're going to, this is kind of the beta version, we're going to see how it works. The goal is to let y'all talk to each other in an easy way. We don't want to make it hard, we don't want to add difficulty to this, but we want different shops to be able to talk to each other and say, hey, I have a Delta drill press from 1972 and I need a new belt cover on the top. And somehow an easy way for y'all to just send out one email that would go to everyone that would let someone easily respond and say, oh, hey, I got that. I have 2 of those. You can have them. So going through UT List. Now this is, we're going to show a lot of screenshots. I'm not expecting anyone to remember this. It's just when you actually do it, it wouldn't be the first time you've seen it. So you've seen it once, and we'll have these screenshots available with instructions on how to actually sign up. You don't have to do this. We're not going to sign you up if you don't want to do it. don't sign up for it, and you won't be included. But it's a fairly simple process. If you can just Google UT list or go to utex.edu/its/mailing list, but just Google UT lists and it'll take you here. You can click this sign up, login, manage button here. It's going to take you to the same place, to this screen here, and you'll see here first login. So for Lori, if you've already done this, you probably already have a login. But for everybody else, you probably don't. You cannot use your EID. So you go to first login, you put in your email address here, and they send you a password, and you continue there. Why you can't use your EID? Because a lot of people with EIDs might want to use the list, so a non-UT employee might be on a list. I don't know what kind of example that would be.
Well, other people outside of UT may use these lists, but they may not have an EID, so they made it so everyone has access. It also eliminates the risk of sending UT EIDs and passwords, them getting jumbled up in the email somewhere. So it kind of, also many different people, or many people would like to use different emails for, say one for a mailing list, so they know when they get a message that it's, coming to a certain email account, and so that's why they do that. It's kind of a complicated, they'll send you a complicated EID, but you can, a password, but you can change it once you log in for the first time.
Right, so if you don't want your work email to get filled with this list, you can just sign up a Gmail account with this. It does not have to be a UT email. So they'll actually send you your password, which we can't talk about. You see right here, it's not a very easy password. Mine got sent to my junk mail, so if you're looking for it in your inbox, it's probably in your junk mail. Then all you gotta do is you type in, not my email, but your email up there, whatever one you're using, plus the password that they send you, and then we called it Machine Shop Forum down here. You can actually go into faculty and staff and search for it alphabetically, or you can just type this in down here and hit search list, and it'll give you our Machine Shop Forum at utlist.utex.edu. And click on that, and then all you gotta do is go to subscriber options, and it'll pop up with a screen that says, would you like to subscribe? You click OK, and they send you an email to confirm you have just subscribed to this. So Karen she is the owner of the forum, is that right?
Now, I'm the owner, so if you have any questions, my email will be in the next slide. I'm the training and outreach coordinator for AHS, so there's my email at the bottom. Or if you don't, for some reason, want to go through that process, if you just want me to subscribe you, just send me an email and say, I forgot how to do it or whatever, and I'll subscribe you to the list. One thing to remember that this is an email listserv, mailing list, whatever you want to call it. So what you send to the group is going to go out to everyone in the group. If you want to send an individual message to someone, this is not the right thing to use. The email address for the list when you want to post something will be machineshopforum@utlist.utex.edu in no spaces. And so we can send that out.
And we can, all this stuff will be available later. Any questions? Everybody knows how to do it now, right? Yeah? All right, so closing. Almost done. Training reports. A lot of the shops, especially shops with students, you have to be able to review training reports, make sure that they have taken the online training. So we have Text Class is the service that keeps track of all training. So when you go to the EHS website and you take the OH 500 training or the new OH 506 for shop supervisors, it actually gets tracked within Text Class. So for y'all to actually be able to keep track of that, of your own employees or your own students who are working in your shops, it's a fairly simple process, and we'll have, again, all this stuff available later. You send an email to this address here, and really, you can title this is the title of the email, and all you gotta do is put authorization in the body of the email. Put authorization request, this, I don't know what it means, it's a code. Oh, there you go, yes, training history. Thank you. And then your EID. And that's all you gotta do. You'll get an email back from someone within text class, and they'll say you now have authorization to run reports. And sure, yeah, so you'll get the confirmation email and you'll be able to run the report. So here again, it's a little harder to find. If you just do utext.edu/careersmart, that takes you here. You can actually click the link here for text class, and then you log in with your EID like we all do every day. Over here, you'll have training history. There's two ways to run training reports. You can do individual queries and group queries. Your individual queries are actually clicking on training history here, and then entering the EID of whoever you want to find out about. So your shop supervisor, you want to know what their training history is, you enter their stuff here, press the button, and it'll actually list every course that they've taken. It's not specific to OH500, OH506, it lists everything. The other way to do a group query is yes, I think you actually have to hit administrative functions here. I mistakenly circled training history. You hit administrative functions here and go to this option here, download training data. And, oh, there you go, never mind. So, training download request, you need to click select detail on that one, and then you just enter in your date. Watch out, it only lets you do one fiscal year, so you can't stretch from August 31st to September something, so it has to be within a contiguous fiscal year. And then just enter in the course ID that you're interested in. So OH506, you hit download information, it'll actually give you a little download for Excel file down here. You just say yes, open it, you open it, and then you can sort by name and just look for, you actually have to actively look for the people that are in your class. It's going to give you everybody that's taken OH506.
Sort by department. You can sort by department too.
Yes, you should be able to filter by department. So if there's students, I don't know if you can just sort by student, but if it's an employee shop, you can just sort by your department. And
Sort by the students.
yes. Let's see. Oh, this is you, right?
Okay, so, thank you guys for coming. Assuming that we have the funds to do this, would you be interested in having a machine shop, workshop annually? Show of hands, yes, no. From you guys? Okay. In addition to it's getting informal, we're going to send you a survey via email within the week. And I want to remind you that we'll place all presentations on the EHS Campus and Occupational Safety webpage, and that will list their screenshots to help you sign up for text class to run your student report. And again, you can run student reports based on department, so you can just query that. And this, we can direct new employees or those that missed the workshop. Okay. We hope that you made some new connections and learned something. We encourage you guys to work together, and I think the virtual lesson board will be very useful. We encourage you guys to visit each other's shops. We'd like you guys to fill out the survey. We can send it to you in the mail, or you can send us comments. Daniel, my contact information is on that contact list. And in closing, we'd like to thank Don Gardner for his, thank you, for donating his time and expertise. We'd like to thank Scott Allen and Mark Phillips for that very informative anti-restart safety demonstration. And I want to thank Neil Crump for his lending his technical expertise. And I want to thank you guys for showing up. So that's all we got. Any questions?